Hi folks, today we're going to go ahead and talk about the power rule. So if we have a function raised to any n power, the way that we can find the derivative is by multiplying out in front n times x, and then we're going to go ahead and power down, so x minus 1. So essentially this is called the power rule. So let's go ahead and see some of this in action. So this is coming from your practice number 1. If I have f of x is equal to 4x squared plus 7x minus 3, I can think about each of these as separate terms, and I can apply the power rule to each. So the derivative of 4x squared means I'm going to take this 2 and multiply it out in front. So 2 times 4 is 8x, and then I'm going to go ahead and power down. So 2 minus 1 is just going to be a power of 1. I don't actually have to write the power of 1. I can just leave it as x. The derivative of 7x. So 7x does have a power of 1, meaning that if I were to multiply this exponent out in front, it would just be 7. And then if I power down from 1, I am 0. So I'm just going to be a constant. So plus 7. And then the derivative of any constant, like again, remember, if we think about the derivative as being a fancy word for slope, well, what is the slope of something that is always 3? Right? Meaning that, like, how is 3 if it never changes? So we know that the slope or the change is going to be 0. So I could be minus 0. Right? And again, I don't need to write minus 0, so I can just leave it as 8x plus 7. Let's see, let's go ahead and skip around to number 5 from your homework. So number 5 says f of x is equal to x cubed minus x to the 5th divided by x. So the way that we use the power rule, meaning that each term has to just be the term or the variable raised to a particular power. So right now we have a quotient, but we can manipulate my quotient to only be powers. So the way that I'm going to do that is if everything is being divided by x, I can go ahead and say x cubed divided by x minus x to the 5th divided by x. And I can actually simplify each of these terms. So we have to start thinking about these as separate terms. Okay, so this term and this term. So x cubed divided by x is going to be x squared, and x to the 5th divided by x is going to be x to the 4th. So this is a much easier expression to go ahead and take the derivative of than this huge quotient. And so the derivative of f is going to be, so 2 gets multiplied out in front, and then I power down, so x to the first power, or just x, minus 4 gets multiplied out in front, so negative 4. I power down from 4, which is going to be an exponent of 3. The same is true of, like, for example, let's skip down to number 9. If I have f of x is equal to 2x times x squared minus 1, you can see that what I have here is a product. So you have two functions, 2x and the function x squared minus 1, and you're multiplying them. So power rule does not apply. Well, I should say the way that it's written here doesn't apply, but we can actually distribute this 2x in for each of the term, and then we can go ahead and use power rule. So the result is going to be 2x cubed minus 2x. And so now if I look at each of these terms, I can definitely apply the power rule to 2x cubed minus 2x. So the derivative is going to be, I'm going to take 3 and multiply it out in front. So 2 times 3 is 6 times x to the 2nd power minus, again, my power is 1 here. If If I multiply that out in front, I get minus 2. No, I don't get minus 2x. I just get minus 2. Because if I power down from 1, I am 0. So I'm just a constant. Don't be scared of playing around with some of those trickier exponents. So for example, number 10, f of x is equal to the square root of x times x cubed minus 2x. So the same thing is applicable to number 10 as it is in 9, which I want to go ahead and distribute. So how do I distribute the square root of x? Well, I want you guys to remember that the square root of x is the same thing as saying x to the 1/2 power. So what we mean to say here is x to the 1/2 times x cubed minus 2x. So when I go to distribute this, I'm going to get, so when you multiply powers with the same base, you add their exponents. So you're going to get x. So what is 3 plus 1/2? That is going to be the same thing as saying 1/2 plus 6/2. So you get 7/2. And then when I multiply x to the 1/2 times 2x, this has a power of 1. So when you are multiplying powers with the same base, you add their exponents. So 1 plus 1/2 is going to be the same thing as saying 2 over 2 plus 1/2, which sums to 3/2. So again, when you add powers with the same, or when you multiply powers with the same base, you add their exponents. So f of x, its equivalent form is x to the 7/2 plus x to the 3/2. So if I use my power rule, multiply 7/2 out in front, I power down. So subtracting 1 from this fraction is the same thing as saying subtracting 2 over 2. So you get 5/2 plus, I'm going to go ahead and multiply 3/2 out in front. And I power down from 3/2, which again is subtracting 2 over 2. So you get 1/2. An equivalent way to write this derivative is to go ahead and change these half powers back into square roots. And so this is going to be 7/2 times the square root of x to the 5th. So as a review, if you have x to the 5/2, that's the same thing as saying x to the 5th times 1/2. So when you take a power and you raise it to another power, you multiply their exponents. So I can go ahead and use that property to kind of undo 5/2 and make it this product. And so what you mean to say here is that you have x to the 5th raised to the 1/2 power, or the square root of x to the 5th. The square root of x to the 5th could also be written as x squared times the square root of x, because again, the square root is asking for what was squared. And so what was squared is you have x squared times x squared times x. So what was squared was our x squared, and then what remains is our x. So you could leave it as the square root of x to the 5th, or you could go ahead and change it to this expression. I don't really care. Again, if it's a multiple choice, you want to watch out for those sort of simplifying techniques. And then so my second term becomes 3/2 times the square root of x. So this could be an equivalent form, or as I said before, you could go ahead and change this term to x squared times the square root of x plus 3/2 times the square root of x. You could even be more fancy, like the simplifying techniques are endless. Each term has a square root of x, which means you could go ahead and factor that out. And then what remains is 7/2 x squared plus 3/2. I mean, you could take it a step further and factor out another 3/2. So kind of practicing between how you kind of simplify the result or the derivative with those powers. It's just going to take a little bit.